Welcome to 16 nearly impossible issues for evolutionists to answer. On the slide, there's my email address in case anyone should care to use it. The main objective is to sketch briefly 16 issues, mostly scientific, among others. Then to claim, by falsification, that evolutionists' proposed solutions, if they exist, to such issues, in which they see a stake, fall woefully short and invariably violate basic, well-known laws of mathematics, including logic, physics, and chemistry, including biology, all in a fast-paced format. All such proposals, Darwin's hypothesis, also known as evolution included, should be corrected, set aside, displaced, or abandoned, and their makers held responsible. Karl R. Popper's The Logic of Scientific Discovery provides ample support for falsification. You can't prove anything, but you can disprove much by repeatable counterexamples. Thomas Alva Edison, who had more patents in his day than anyone else, said, "We don't know a millionth of 1% about anything." First, some preliminary considerations undergirding the presentation. 3 elements to consider always. Data, what would be the sources? Epistemology, what would make something true? Logic, what would constitute standards of proof? One epistemological paradigm consists of 4 philosophical schools of thought. Absolutism, which means someone said so. Empiricism, which means someone tested something. Pragmatism, which means someone found that something works. Existentialism, which means someone showed that something occurred. The preferred school of thought for this presentation is a dispassionate empiricism, not logical positivism, where anything and everything meaningful must be empirical, but that empirical phenomena always conform to the scientific method with collected evidence that is repeatable, observable, measurable, testable, falsifiable, validatable, verifiable, correlative, cross-correlative, in the ever-present questioning eye of the skeptic. Accordingly, all empirical evidence must conform to that standard. And there might be some skeptics here whose comments would be welcome in time. The backyard skeptics have said that they need empirical evidence of any claim to accept it as true. Agreed, but not to be an evidentialist. Modifying the thoughts of Nobel laureate George Wall somewhat, nowadays the impossible becomes the possible the plausible, the plausible the probable the certain. None of that chain of implications conforms with science. Though the lowest to highest probabilities in empiricism range only from 0+% to 100-%, still one must first show why the impossible should become the possible, etc. Else, we're saying that we believe in miracles over science, implying most anything might occur, implying there would be no way to discriminate between the reasonable and the ridiculous. Non-empirical categories, such as the historical, the spiritual, the unsensed, don't belong in this presentation, but might instead in a courtroom, admitting circumstantial evidence. Scientific laws, such as those of mathematics, physics, chemistry, or whatever, either hold or do not hold. If the latter, then no one can employ such laws at all, and any dialogue incorporating them has no meaning, and thus should cease completely. There is no empirical basis to show that any such laws, which do hold now, did not hold in the finite past. Rather, if anything changed, Presumably, the universe did instead. Scientific laws do not apply to something that does not exist. Something immediately conforms to the properties that it has upon its coming into existence. Conforming includes the possibility of changing relative to changing inputs and environment. If any property changes thereafter, then conformation accords with the revised property. Verified scientific laws don't displace other verified scientific laws. For someone claiming a new and shiny hypothesis, what about the old and dull known scientific laws? Why wouldn't they still be true? Or in response to Stephen Wolfram's live 1 February 2003, a new kind of science talk at Caltech, his alma mater, 3 of its skeptical professors said, a new kind of science better agree with the old kind of science. And I was there to see that talk. All scientific claims assume expected behavior per mathematics, physics, and chemistry. No one has all of the data all the time everywhere. Data has noise and contamination. So, all conclusions modifiable by more evidence and or review are always held tentatively. Interpolation is putting points between known points. Extrapolation is putting points beyond known points. Because extrapolation is subject to greater uncertainty and a higher risk of producing meaningless results, it is much more likely to cause mischief than interpolation, particularly if extending back into the unobservable, unrepeatable past. An old carpenter's maxim: never extend a short line into a long line. So this presentation will not discuss age except in a few necessary places. But note that, everything else equal, the longer a process, the more the associated entropy. In darkly humorous form, the 3 laws of thermodynamics are valid for all systems. Conservation. Winning is impossible. The best possible outcome is breaking even. Dissipation. Breaking even would be possible only at absolute zero. Limitation. Absolute zero is unattainable. Sources. A footnote preceding Walter J. Moore's Physical Chemistry as modified. And Sir Arthur Eddington's Entropy is Time Zero in Chapter 8, Section 2 of Gordon Barrow's Physical Chemistry is along similar lines. There's also a zeroth law from the past that says that playing the game is mandatory. Incidentally, that older zeroth law differs completely from a modern zeroth law, which says that if 2 thermodynamic systems are each in thermal equilibrium with a third thermodynamic system, then they are in thermal equilibrium with each other. So, if nothing else intervenes, losing the game is the only outcome every single time. For the purposes of this presentation, define evolution, whether chemical, stellar, molecular, cosmological, language, societal, biological, or abiogenesis, as change, usually progressive, by unguided processes, to the exclusion of any and all external influences, for example, a vibrating string left to itself. Because it contradicts thermodynamics, evolution never has been, is not now, and never will be feasible anywhere at any time. Define an evolutionist as one who holds to evolution, especially to an infinitesimal to man progression through successive stages, not just to Darwin's hypothesis, also known as evolution. Sources. See covers of 9 textbooks with the word evolution in their titles, discussing cosmological evolution, but little, if anything, about biological evolution. To date, evolutionists have been left unchallenged on non-Darwinian issues, and their proposals have been effectively left unfalsifiable. If for some reason you don't like the words evolution and evolutionist as defined above, then use other words instead that embody the concepts in the definitions. Evolutionists often futilely employ wands, which are words or phrases to justify a position without rigorous scientific support, such as time, chance, quantum fluctuations, multiverses, Big Bang, hyperinflation, gravity, supernovae, dark matter, dark energy, crystal formation, open systems, string theory, subduction, brains, Boltzmann brains, natural selection, consensus. Many of these wands will appear in the presentation. Some of them may exist, but not have sufficient justification toward certain desired goals. Others may not actually exist. As the accompanying slide depicts the list of wands in 2 columns, see a rough one-to-one correspondence between the entries on the left side and the entries on the right side. On consensus, wand. From Michael Crichton, Aliens Cause Global Warming, 17 January 2003. Quote, I want to pause here and talk about this notion of consensus and the rise of what has been called consensus science. I regard consensus science as an extremely pernicious development that ought to be stopped cold in its tracks. Historically, the claim of consensus has been the first refuge of scoundrels. It is a way to avoid debate by claiming that the matter is already settled. Whenever you hear the consensus of scientists agree on something or other, reach for your wallet because you're being had. Let's be clear. The work of science has nothing whatever to do with consensus. Consensus is the business of politics. Science, on the contrary, requires only one investigator who happens to be right, which means that he or she has results that are verifiable by reference to the real world. In science, consensus is irrelevant. What is relevant is reproducible results. The greatest scientists in history are great precisely because they broke with the consensus. There is no such thing as consensus science. If it's consensus, it isn't science. If it's science, it isn't consensus. Period. Besides, science by consensus employs the ad populum fallacy. That's the fallacy that 50 million Frenchmen can't all be wrong. Oh, yes, they can. From source, Dr. Rob Stadler's The Scientific Approach to Evolution. High confidence science criteria: repeatable, directly measurable and accurate results, prospective interventional study, careful to avoid bias, careful to avoid assumptions, sober judgment of results. Low confidence science criteria: not repeatable, indirectly measurable, extrapolated or inaccurate results. Retrospective observational study, clear opportunities for bias, many assumptions required, overstated confidence or scope of results. Naturally, high confidence science should take precedence over low confidence science, wherever and whenever possible. We would prefer seeing high confidence science rather than low confidence science. Claim: far-term evolution in all secular senses is low confidence science, if any science. Claim: ever begging for research money often beclouds many scientists. particularly professors, from seeking the truth versus promoting the thoughts of the powers that be. Denote a typical evolutionist response by E, and an impartial analysis by A throughout the talk. Here then are the presentation's 16 issues, which are brief sketches that range over cosmology, physics, chemistry, biochemistry, biology, and information. Since you're all speed readers and comprehended all the issues immediately, we can all go home. No? Well, then I guess we'll have to stay and work a bit. In the cosmology section, issue number 1, why does anything exist? Issue number 2, did the universe always exist? Issue number 3, did the universe cause itself to exist? Issue number 4, how can the universe avoid heat death? Issue number 5, how can any material travel faster than the speed of light? In the physics and chemistry section, issue number 6, what is the origin, transportation, and distribution of carbon? Issue number 7, how do any stars exist? Issue number 8, how do moons form? Issue number 9, what is the ongoing source of comets? Issue number 10, how do any elements heavier than iron exist? In the biochemistry, biology, and information section, issue number 11, how do peptide bonds exist? Issue number 12, how do proteins have only L amino acids? Issue number 13, what turned non-life into life? Issue number 14, how does metamorphosis occur? Issue number 15, how do major morphological changes occur? Issue number 16, what creates information from gibberish? In the cosmology section, issue number 1, why does anything exist? Why is there something rather than nothing? A singularity is the starting point. Some might say accidental. If nothing exists, then there is no space, no material, no people, no meeting, nothing. And from nothing, nothing comes. Else, not logical, violates mathematics. Relevant. To do something must first be. Related, a humorous summary about doing and being from Paul Kroom, the Dallas Morning News, January 1968. To do is to be, attributed originally to Lao Tzu or Lao Tse, later to others. To be is to do, attributed originally to Dale Carnegie, later to others. Doobie doobie doo, Frank Sinatra. Source. Roget's pocket thesaurus is a treasury of synonyms. In the thesaurus's 1,000 categories, whose structure of synonyms and antonyms forms an excellent study of the language, category number 1 is existence, and the latter categories provide possible causes of existence. These two category sets thus bookend all of the other categories. Why this particular total mass? The current estimate for the total mass of the universe is 10 to the 80th atoms, plus or minus 1 or 2 orders of magnitude. Why not 10 to the 79th, plus or minus? Why not 10 to the 81st, plus or minus? Why not some other value, plus or minus? Why is the amount of matter much, much greater than the amount of antimatter? One might expect equal amounts of each. Since the overwhelming evidence, with none to the contrary, says otherwise, the logical inference is that the universe did not originate from a neutral starting point. Source, Wikipedia article on antimatter. We might well be very concerned if the amounts were equal or nearly so because of particle/antiparticle annihilation. But note the following. About quantum fluctuations, the public belief is that nothing can turn into everything eventually by first turning into a particle and its antiparticle. And if they were to collide, they would, in annihilation, turn back into nothing. Really? Among other things, if a particle and its antiparticle, coming from nothing or not, collide, they would form energy and maybe other particles and antiparticles, but not nothing. The empirical evidence is overwhelming, with none to the contrary. Else, one could form unlimited amounts of energy from nothing, which violates physics. For example, the first law of thermodynamics. Instead, what's being touted is that there is an already existing energy field out of which a particle and its antiparticle can come and into which they can go. But then the origin, purpose, and destiny of the energy field would remain without explanation. Why this particular mass distribution? The mass of the universe is not uniformly distributed, but in clumps. Related, the Jeans instability criterion implies that if there is enough mass/energy in a small enough volume, gravity will collapse it. Virtually every secular physics department in the world teaches such a statement or a logical equivalent. Claim a Big Bang never could have occurred. Support that the most stable configuration for the universe would have all of its mass/energy co-located in an infinitesimal follows immediately from the Jeans instability criterion. But such a notion would coincide with the initial conditions for mass/energy for a Big Bang, entropy accepted, and space expansion possibly accepted. Any expansion would make the universe less stable. So no expansion should, could, or would have ever occurred, ergo no Big Bang. Violates physics. If so, then the human race has wasted trillions of dollars on a completely false hypothesis. Note, the support says nothing about an origin of such an infinitesimal, only noting the similitude between such an infinitesimal and the most stable configuration for the universe. My best chess student deduced the second sentence of that disproof from just the first sentence. Then a former PhD student in physics and then a former aerospace worker also did so. There has been no shortage of reactions. As matter gets denser, time slows down. So if all the mass/energy were co-located in an infinitesimal, time would stop. Dr. Beresford, Neil Parlett. Then there's no time for an expansion. The laws of physics would break down. Then one cannot argue by the laws of physics. Evolutionists use modern physics arguments. Dr. Jake Hebert. Claim, no, evolutionists use only gravity in their arguments. The space, not the material in the space, is what would be expanding. So use quantum gravity theory, Dr. John Gideon Hartnett. In a supposed Big Bang, at least some of the material in the space should be traveling at, or nearly at, the same rate as the rate at which the space would be expanding. Also, Dr. Hartnett concedes that there is no quantum gravity theory currently. No, Doctors Hebert and Hartnett are not evolutionists, but rather suggested how evolutionists might argue against the Big Bang disproof. Issue number 2, did the universe always exist? Not, did the universe always exist essentially in the same form that it now exists, but rather, did the universe always exist in any form? Yes. No. Else the universe would have already completely dissipated, not a long time ago, but an infinite time ago, contrary to observation. Otherwise, violates physics, specifically the second law of thermodynamics. Colloquially, the universe is either open or closed. Strictly speaking, the universe is open, closed, or isolated. If open, then outside entities, for example, a creator God, could enter. If closed, then the universe's fate would be completely determined by thermodynamics. Issue number 3. Did the universe cause itself to exist? Note, answering yes to this issue would contradict answering yes to the previous issue. Yes. No. Else, to cause itself to exist, the universe would have had to have existed before it existed, or alternatively, the universe would have had to have simultaneously existed and not existed. The parts of either form would agree in time and context. Or if the universe could cause itself to exist, then each and every one of the parts of the universe could cause itself to exist. But not any one thing could cause itself to exist. Regardless of form, the argument is a reductio ad absurdum. So any notion of the universe causing itself to exist violates mathematics and physics. Regarding a multiverse, universe means everything. But even so, any hypothesis that another everything exists lacks evidence passing withering, rigorous scientific scrutiny. From issues numbers 1, 2, and 3, one can form a cosmological argument, namely that the cause of the universe must be outside the universe. Reviewing. Issue number 1, basis. Does the universe exist? Yes. Issue number 2, did the universe always exist? No. Issue number 3, did the universe cause itself to exist? No. Therefore, the universe has no material cause, because the same logic would apply to any subset thereof. There are only 2 alternatives. Alternative number 1, the universe has no cause, which is an existential, unscientific position. Alternative number 2, the universe has a cause, but that cause must be immaterial. From alternative number 2, choose from the following list of possible immaterial causes: fairies, leprechauns, gnomes, flying spaghetti monster, God, other, i.e., you add to the list. For example, quantum fluctuations, multiverses, brains, Boltzmann brains, etc. Of that list, only God has any testimony. So, if anyone should ever say a creationist's hypothesis is no better than that of a flying spaghetti monster, one appropriate retort says, kindly, hopefully, I don't believe in a flying spaghetti monster. You do. And there should be no argument thereafter. Claim, evolutionists, not creationists, believe in a flying spaghetti monster. Also, one may rearrange the cosmological argument blocks to form a waterfall chart. Issue number 1, basis. Does the universe exist? Yes. No is obviously false. You belong in an insane asylum with little white coats. Does the universe have a cause? Yes. No is unscientific. Is the cause material or immaterial? Choose material and follow the logic. Issue number 2. Did the universe always exist? No. Yes would violate physics, the second law of thermodynamics. Issue number 3, is the universe self-caused? No. Yes would be not logical, violates mathematics. So the cause must be immaterial. The waterfall chart is powerful because it displays a mutually disjoint decomposition of the set of choices. That set of choices is the entire set of choices. There are no other choices. There never have been any other choices. There never will be any other choices. Issue number 4, how can the universe avoid heat death? Not that the universe unabatedly heats up, but rather unabatedly dissipates its heat. The universe could and or did oscillate and or cycle. The universe cannot avoid heat death, else violates physics, particularly the second law of thermodynamics. If nothing intervenes, eventually the disorder of the surroundings would overwhelm any supposed pockets of order, and then the universe's energy would eventually completely dissipate by Le Chatelier's principle, and there would not be any useful energy left, and the universe would reach what the mob calls room temperature, about 2.7 degrees Kelvin. As for whether there is any hope for the universe otherwise, such as a constant or steady state universe or something else as stated earlier, any new kind of science better agree with the old science where the thermodynamics are still there, whether using Roger Penrose's cycles of time, thesaurus, or not. Issue number 5. How can any material travel faster than the speed of light? Space can expand faster than the speed of light. There is no direct observational evidence of any material or energy traveling faster than the speed of light, understood to include possibly a positive infinitesimal, else violates physics, even if modern physics adherents claim otherwise, because at least some material, for example, material in any space traveling that fast, would also be traveling faster than the speed of light. Claimed quantum tunneling does not refute that notion. Support. Things do not appear instantaneously on one side of a barrier that were on the other side of the barrier. Beliefs to the contrary conveniently forget that the probability of an event being zero, which would exist at a node in the corresponding function, does not imply that the event cannot occur. Such events can and do occur in a continuum. Only for discrete events could such an event not occur. Those who would involve themselves with a Big Bang, which never could have occurred, would need to explain how heat could travel across the whole universe such that the volumes of outer space, far from heat sources, have temperature approximately 2.7 degrees Kelvin, consistent with cosmic background emissions. A supposed hyperinflation, wherein the universe expanded much, much faster than the speed of light after a supposed Big Bang, would be just for shoring up currently accepted hypotheses, but not satisfying the criteria of empirical science, especially observational evidence, nor verifying whether or not such an event had occurred, nor providing any reason why at some particular time larger than Planck time, such as 10 to the minus 35th seconds, 10 to the minus 31st seconds, or 10 to the minus 30th seconds, with no such time interval measurable by present devices rather than at some other particular time, nor establishing that such an event would have occurred at only one time, nor showing how such a supposed hyperinflation rate would have ever fallen to a normal expansion rate, the graceful exit problem claimed solved in 1982. On 5 July 2015, Roger Penrose, no friend of creationism, claimed falsification of hyperinflation. Quote, inflation isn't falsifiable, it's falsified. P, background imaging of cosmic extragalactic polarization, did a wonderful service by bringing out all of the inflationists out of their shell and giving them a black eye. Source, CMB at 50, Cosmic Microwave Background 50 years later conference, as cited in the Wikipedia article, Inflation, Cosmology. Hugh Ross's reasons to believe has had no answer to this issue, nor to the next issue. At this point, I entertain questions. You may stand up and stretch if you wish. Any questions? First about definitions, then about and terminology, and then about the issues themselves. Any at all? I take any questions. Any? Well, you can stand up and stretch, I guess, for a few minutes. Do you have any questions, Dave?
They used to say Penrose, who were kind of falsified.
Excuse me?
You said that Penrose kind of was falsified.
Yes, he did.
Well, just because one instance says something was falsified, that in itself doesn't necessarily mean it's actually been falsified. There have been all kinds of people out there claiming things have been falsified and found to be wrong. So I'm not saying he's wrong, but I'd say just one person saying it without some kind of additional verification is probably not something I'd really like to land on very much.
Well, you're free to check out his claim if you like. Yeah, Roger Penrose is not an amateur in this field. He worked with Stephen Hawking and produced co-wrote papers with him. I hope you know that.
Well, physicists disagree with each other all the time.
They certainly do, but it is something worth considering.
Yeah.
It is not something from our side of the aisle. It is something from the other side of the aisle.
It's an argument against problems.
Mm-hmm. Yeah. Any other questions, comments, and so forth at this point? You have any? Anybody?
I like the use of the props.
Thank you. Well, I'll continue to use them, and hopefully that will do us a bit of service. Anything else? Any other questions? Comments on the introduction or the first 5 issues? Well, if not, I would invite you to take your seats at your earliest convenience, and I shall resume. In the physics and chemistry section, issue number 6, what is the origin, transportation, and distribution of carbon? Which examples of carbon, seen or unseen, does the slide portray? One example at a time, I ask from the audience. Yes.
Diamond.
Diamond is one. Another one. Please? Did I hear another answer? Which examples of carbon in the slide?
Oh, coal.
Coal is one. Another?
Living organisms.
Yes, I call it the chia pet material. Any others? Seen or unseen? Yes? Peat I'll count in the same category as the chia pet material, but certainly yes. Any other?
The air.
What about the air?
The air contains a component, or it's partly made out of carbon dioxide.
Carbon dioxide is one example. Any others? Yes?
Carbon monoxide.
Carbon monoxide. Any others?
There's probably some carbonates in the rocks.
Carbonates in the rock. Somebody suggested lime, possibly. Yes. What else? Yes?
Methane.
Methane. I think that would be enough for now. In fact, it's every one of the examples I have here. It's the first time we've had all 7 examples given in a talk.
It was an advanced group today.
Let's continue to hope so. The issue is not whether there is carbon, but rather from where did it originally come? The original dark matter. There it is in the periodic table at element number 6. Explainable partially. Origin by triple alpha process, the only known example of the anthropic principle. Transportation by supernova. Distribution by gravity. There's the triple alpha process. We'll cover that in a moment. Not explainable. Violates physics galore. Origin, sketch of the triple alpha process. Two helium atoms formed from stellar hydrogen fusion come together to form beryllium-8, and before such an unstable transitory species could fall apart in 10 to the minus 15 seconds, a third helium atom joins the fray to form carbon-12. Such an extremely improbable, unstable process has only one nuclear resonance and can only occur in stars nearing the end of their red giant phase. Sources: 1983 Nobel Prize in Physics for 1940s to 1950s work. Anyway, the Evolution Cruncher, which goes into it somewhat, but not as good as it could. One of the most striking of such apparent coincidences was revealed with William Fowler's confirmation of Fred Hoyle's remarkable prediction of the existence of a particular energy level of carbon, which, had it not existed, would have meant that the production of heavy elements in stars would not have been able to proceed beyond carbon, leaving the planets devoid of nitrogen, oxygen, chlorine, sodium, sulfur, and numerous other elements. Source: Roger Penrose, Cycles of Time, page 171. Transportation would take place later, but then only by supernovae. No one has directly observed a star forming carbon, let alone sending it anywhere, for example, Earth, let alone accounting for the distribution on the Earth. To borrow some more trouble, how would gases nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, radon, the latter in 3 of 4 uranium to lead sequences, and liquids bromine, mercury, ever reach any planets? Note, like so many other stars, the sun hasn't had a supernova, and further, never has been and never will be large enough even after becoming a red giant to undergo a supernova. Were there ever enough supernovae in the Milky Way to account for Earth's carbon? Naive notion. To account for all of the Earth's carbon, compare the number of supernovae available against the number of supernovae needed. Approach: starting point to formulae, to assumptions, to computations. Following is a back-of-the-envelope feasibility computation. Starting point: 1. Each computation relies on assumptions and uses the most digits available. 2. First order superposition applies memorylessly everywhere. 3. Supernovae always occurred at a regular rate, distributed similarly. 4. All supernovae in question had equal mass and energy content and finished. 5. Each supernovae blasted all of its contents uniformly, linearly, radially, outwardly. 6. Sun-sized star required S equals 6 previous supernovae to form in the first place. And 7. A screen would catch all of the incoming carbon to Earth's volume. In this diagram, I have pictured a supernovae at the center, extending its clear-out radius to 30 light years and having a mass generically as magenta M2, which could be either M2, M2 prime, or M2 double prime, we shall see later. Its volume is the shell represented by V2. We have Earth favorably situated all the time at 30 light years away with mass 1 of its carbon and a volume for the Earth of V1 and for the frustum outward from the Earth as V1 prime. Consistent with that figure, the number of supernovae available is equal to T2 times the number of Milky Way supernovae inside radius 1 divided by T1, all times radius 2 divided by radius 1 cubed, where the number of Milky Way supernovae inside R1 is equal to the total Milky Way supernovae inside radius R1, which in turn, that number is equal to 1. T1 is the given time period. There are two available. One of them is 160 million years, and the other is 240 million years. These both appear in the literature. T2 is equal to the given time period 2, which is 13.7 billion years, the presumed age of the universe. R1 is the given radius 1, which is referenced to 33 light years, and R2 is the given radius 2, which is referenced to 100 light years. Brackets indicate the greatest integer per worst case computations. Plugging the numbers into the formula, the number of supernovae available is either equal to 2383 for T1 equals 160 million years, or 1589 for T1 equals 240 million years. This number of supernovae needed formula, recall this figure briefly. One supernova sends magenta M2 to V2, of which small m less than magenta M2, in other words, a subset of magenta M2, goes to V1 prime. Comparable material densities equal implies magenta M2 divided by V2 is equal to little m divided by V1 prime, which implies little m is equal to V1 prime times magenta M2 divided by V2, which implies the number of supernovae needed as a preliminary is equal to m1 divided by little m, which is equal to m1 divided by v1 prime density divided by magenta m2 divided by v2 density. It's a very nice result. Not immediately evident by assumption 6 is whether to multiply by s, divide by s, or even involve s to obtain the final number of supernovae needed. For the worst case, divide by s so that the number of supernovae needed final is equal to m1 divided by v1 prime divided by magenta m2 divided by v2, all divided by s, greatest integer function in each case. Recalling the figure one more time. We need, in other words, to compute m1, v1 prime, m2, and v2, where m2 could be any of those three. Let's start with m1 and v1. These are around the Earth. The Earth's carbon mass is said to be approximately 1.00045810 times 10 to the 20th kilograms. The source for this data is the University of New Hampshire. So we have m1. The Earth's volume is approximately 4/3 pi its radius cubed, which you can see that figure. If instead we're taking the frustum, which is more useful, we use a flat end cone approximation. The final answer is 4/3 pi times 1.04 times 10 to the 23rd kilometers cubed, where r is equal to the radius of the Earth, 6378.1 kilometers. H is, you recall, that radius to the clear out point of 30 light years, and little h is 100 minus 30, or the remaining 70 out to a total of 100. By the way, the claim is for any r divided by h, note, greater than 0 by similar triangles, no matter what the value of h, the essential results would remain unchanged. So you could choose anything you want to at that point. Still have the same results. Now that we have M1 and V1, let us go on to M2 and V2. M2 is the mass of the sun, which is approximately 1.989 times 10 to the 30th kilograms. And you can use as the source any good textbook, such as Halliday and Resnick, for example. The mass of a giant star, where it's a million times that of the sun, would multiply that figure by a million. If we have a regular giant star, then we need to employ a few reductions. A carbon fraction of 0.004 would be suggested, a blast fraction of 0.75 would be suggested, and a gravity factor en route to Earth of 0.1 would be suggested. You may choose other figures, and that will give us the result that we see, 5.967 times 10 to the 32nd kilograms. We have M1, we have M2. We have V1, and now for V2. The supernova shell volume is the volume between the outer radius and the inner radius, which is equal to 4/3 pi times 8.24 times 10 to the 44th kilometers cubed. Let's put all that together to form our results now. Again, reminding ourselves of the figure. If we were computing relative to the Earth volume, when plugging in the figures, we get that particular number of supernovae needed. Obviously, way too many to ever satisfy. So instead, we shall use the Earth's frustum, that is, the screen that catches the carbon going out, because that would be a reasonable assumption. And there, the number reduces to 6.6408 times 10 to the 10th supernovae needed. If we had an all-carbon giant-sized star, then we reduce it even further to 66.408. If we had a regular giant star, then it would be 221,360,000. Now, we have our number of supernovae needed. We had before that the number of supernovae available. Let us compare the two. To show how far off we divide the number of supernovae available into the number of supernovae needed and subtract 1. If we have 160 million years as our T1, then we're off by a factor of 26 for all carbon stars, or 92,890 for regular stars. If instead it's 240 million, then we're off by a factor of 40 for all carbon stars, or 139,306 for regular stars. Let us summarize the results. No matter how you want to slice it, the Milky Way supernovae cannot account for Earth's carbon. You'd have to have at least 26 times as many supernovae as have ever existed, besides the ones that did, to account for that carbon. In other words, even with extremely generous assumptions to the opposing side and none to this side, all the Milky Way supernovae that have ever existed within 100 light years of the Earth, even all put together, cannot possibly account for all of Earth's carbon, and it's not even close. Caveat: changing data and or assumptions may change the computation. Contrast: the widely accepted secular scenario is completely different, relying instead on enrichment, starting with population Roman numeral 3 stars, presumably containing hydrogen, helium, maybe trace amounts of lithium and or beryllium, although no one has ever detected any population Roman numeral 3 star currently in existence. Continuing to population Roman numeral 2 stars, presumably containing more elements, and on to population Roman numeral 1 stars, presumably containing all the elements except any man-made. So far, corresponding quantitative computations have not become readily available. Regarding distribution, without further qualification, all of the carbon from supernovae would be scattered more or less uniformly on heavenly bodies and or in outer space, and in any event, not in economically mineable or viable deposits. Non-uniformity of the world's coal deposits by chance is very improbable. Coal exists mostly in Siberia, Australia, the northwestern United States into Canada, two roughly parallel southwest to northeast bands in the middle of the United States, and scattered areas in Asia and in other places miles deep, thousands of miles long, but in any event, not in either Brazil or Central Africa, which teem with vegetation. Even more improbable is a molten lake of carbonates the size of Mexico, 217 miles below half the western United States, discovered in 2017, discovered by more than 500 seismic sensors, which does not accord with subduction. Subduction also cannot account for the even more improbable quadrillion tons of diamonds from 90 to 150 miles below the entire Earth's surface, discovered in 2018. So far, neither the evolutionists nor the creationists can account for the distribution. Issue number 7, how do any stars exist? This issue comes in two parts. Expanding universe approach. Stars formed by gravity anyway, per the Jeans instability criterion. Violates physics. Assume all of the universe's mass resides inside an infinitesimal. A Big Bang occurred, even though it never could have occurred. One result of which is a universe of uniformly distributed hydrogen gas. Recall Newton's first law. Would anybody like to recite Newton's first law? Yes.
Object in motion tends to stay in motion unless acted upon by an exterior force.
And
The second one?
an object at rest tends to stay at rest. Very good. Now for a naive view. As the volume would increase, the hydrogen gas particles would keep going and never stop going away from each other, rather than what would be needed to form a star, viz., coming together and together and together. And thus, the longer the time, the even less the opportunity that the particles would ever come back to each other. There is no external device for compressing gas to liquid or solid, at least in outer space. But even if there were, removing such a device would have the liquid or solid returning to gas. Further info sources. Physical chemistry, physics, thermodynamics books, such as I cited earlier. These two and this one down here. So the universe should not have stars yet. But there is a flip side. Further, assume the universe is a generous 20 billion years old. Current estimates suggest that there are greater than or equal to 2 times 10 to the 23rd stars in the universe. Then the universe should have produced greater than or equal to 10 trillion stars per year on average, for each and every one of those 20 billion years. While the number for any given year might have been more or less, the average number of stars produced each year would still need to be greater than or equal to 10 trillion. Yet, there has been no report by radio, television, newspaper, internet, or otherwise of averaging to that quota of stars every single year. In fact, no one has ever directly observed even one star form. Static universe approach. Preceding remarks challenged. Compression must eventually defeat expansion. Violates physics. By applying Jeans instability criterion, a Big Bang never could have occurred. Even if there had been a Big Bang, one collapse would take approximately 188.9 billion years, many times the presumed age of the universe of 13.7 billion years. Derived from source, University of Iowa physics notes. Or maybe approximately 80 billion years plus or minus a large number with fragmentation. Still much larger than 13.7 billion years. Less collapse time would require dark matter. There is no directly observable evidence of dark matter. Dark matter is today's phlogiston. None found in 40 to 50 years. The resulting inferences are storytelling. John Gideon Hartnett. An ad hoc alternative, modified Newtonian dynamics, MOND, still requires some dark matter. Further, there exists no population Roman numeral 3 stars, field tests, validation, verification. Further, there is no accounting for unmodeled dynamics perturbations. Conclusion, either way, unguided formation of stars is an unsubstantiated hypothesis, and it's long since time to formulate a better hypothesis instead. Issue number 8, how do moons form? Moons form by impact and or nebular hypothesis and or capture by a larger object. Even assuming already existing stars and planets violates physics. 2 cases. 1, no solid moon could have come from the Earth. For an impact, the likely outcome is absorption, for example, meteorites all the time. If impacting into the Pacific Ocean region, there better not have been an ocean there. To form a moon, any ejecta fragmenting all along the way, going up or down, must exceed the Roche limit, a particular distance out from the center of an object. Since tidal forces overwhelm the gravity that might hold the satellite together within the Roche limit, no large satellite can gravitationally coalesce out of smaller particles within that limit. Source, Wikipedia, Roche limit. Attain enough sub-escape velocity, in other words, a Goldilocks velocity, enough velocity to stay away from the Earth, but not too much velocity to escape beyond the Earth. Collocate, very unlikely, even though particles in the same orbit can never reach each other, because material in the orbit, but at different places in the orbit, can never achieve a different velocity from any other material in the orbit, and so cannot reach or be reached by any other material in the orbit. Particles from a nearby orbit might attract by static electricity, or not. Compactify, extremely unlikely, no known source, and also requires chemistry. Acquire the proper tangential velocity for an orbit with no known source for such a force. Never mind that any orbit requires very exacting conditions. Summary, how could Earth's moon form? 1, the impacting object must possess enough mass to cause material to fly up from the Earth. 2, even if one is satisfied, the isotope amounts / ratios for the elements, such as potassium, must agree, but they don't. 3, even if 2 is satisfied, that material must fly beyond the Roche limit. 4, even if 3 is satisfied, that material must have enough velocity or it will fall back to the Earth anyway. 5, even if 4 is satisfied, that material cannot have too much velocity or it will escape beyond the Earth. 6, even if 5 is satisfied, that material must collocate, even though material in the same orbit, but at different points in the orbit, from other material in that same orbit, can never reach any of the other material in that same orbit. 7, even if 6 is satisfied, that material must compactify, requiring more than gravity. For example, chemistry, and no known source of compactification. 8, even if 7 is satisfied, a tangential force must exist and be sufficient to cause an orbit with no known source of such a force. 9, even if 8 is satisfied, the orbit could not satisfy the current conditions that exist for the moon's orbit around the Earth because of the time scale. The most likely path for material to escape the Earth would be straight up, because otherwise the likelihood of material falling back to the Earth would be greater. So the most likely orbit would be geosynchronous, orbiting the Earth once per day or nearly so. So the only current secular hypothesis for the moon's orbit of once per month would require tidal forces interacting between the Earth and the moon to achieve the current orbit. However, the estimated time to reach the current orbit from such a presumed set of circumstances would be much shorter than the secular estimated age of the moon, derived from source. Brian Gied, Tidal Friction, University of South Dakota, Vermilion, 2005. General sources, W.M. Smart, Textbook on Spherical Geometry, Chapter 5. Halliday and Resnick Physics, Chapter 16, Section 7, and others. Palavin and Stevenson in 2007 proposed an Earth-Moon exchange through a silicate vapor comprising a silicate atmosphere and magma disk with moonlets beyond the Roche limit, extending outward from the Earth core, resulting in a Pinocchio effect. With prediction delta 41 potassium moon less than or equal to delta 41 potassium Earth, contrary to the actual 41 potassium data. Lockett et al. 2016 proposed a mantle atmosphere disk, bulk silicate Earth composition, resulting in moonlets in a bloated Pinocchio effect to reverse the aforementioned less than or equal sign to the correct greater than sign. Neither of these two papers address the bulk of the aforementioned objections. Most solar system moons orbit the gaseous planets, Jupiter, Saturn, Uranus, Neptune. 2. No solid moon could have come from a gaseous planet by blasting the planet. The nebular hypothesis doesn't work either because, among other things, the moons being solid differ in composition from the planets being gaseous. Also, in the solar system, there are no binary combinations, and neither Venus nor Mercury has a moon. The capture theory is too coincidental. The isotope ratios disagree with the predictions. Besides such considerations, there's no evidence of other tribes. We get scared enough from a meteorite coming toward us. Think what would occur if we saw a moon coming in our direction. About theories of moon and planet formation, many of them refuted. Source, Wikipedia article on the history of solar system formation and evolution. Take note. Hypothesis. Claim there are no plausible theories currently on moon formation. Supplement having to do with the capture theory. I invite you to skim through that if you like. Okay? Are we still reading? All right. Issue number 9. What is the ongoing source of comets? 2 cases. 1. Many most comets. Short-term comets have an orbital period less than or equal to 200 years. Long-term comets have an orbital period more than 200 years. Kuiper belt and or interplanetary disk. No actual evidence of source yet. Spike Saris doubts whether the Kuiper belt or interplanetary disk exists. 2. Other comments. The Oort cloud. An Oort cloud would be like an automatic pitcher of dirty snowballs, or whatever comprises comets, conveniently, of course, to compensate for comets that are losing their mass, falling into the sun, etc. Such an Oort cloud presumably would be very far away from the solar system and cold, evoking images of Santa Claus. Outside of recent claims for only a few objects, there is no actual evidence of an Oort cloud, not such that anyone can point to it and say that that's where the origin of the otherwise unexplained comets is. Violates physics. No other secular hypothesis exists yet. Issue number 10. How do any elements heavier than iron exist? See iron in the periodic table's 4th row, with manganese to the left, cobalt to the right. See the average binding energy per nucleon curve. Source. Any good modern physics text, such as Widener and Sells, Chapter 9, Section 6. That curve attains its maximum at approximately mass number A equals 55 near iron. A equals 56. Element 26 in the periodic table. Starting with hydrogen, element 1, periodic table, all of the elements up through iron, but with difficulties along the way, for example, carbon, can form by fusion, but no other elements can, except maybe 2 isotopes of nickel. Generally speaking, iron is more favored to form than any other element is favored to form. Nucleosynthesis methods, including the S-slow and R-rapid processes, formed all mass greater than 1 elements. Mass greater than 56 assumes supernova. Mass greater than 210 also requires the R process, in which case supernova would be active participants. Nucleosynthesis methods oppose the average binding energy per nucleon curve for mass greater than 56. Fission from higher atomic weight elements would not be possible because those elements would not yet exist. As are true of carbon, the transportation and distribution of the elements would make them not economically mineable or viable, and their ores would be unexplained. Violates physics. Summary of the said results. See the periodic table through Lawrencium and supposed methods for producing elements. Arguments regarding origin, transportation, and distribution of carbon apply similarly to the origin, transportation, and distribution of other elements, heavier than iron or not. See a map of the world's mineral deposits. Note how the deposits are not uniformly scattered but in clumps. For example, most of the precious materials are located in politically hot spots, like South Africa, Russia, China. Take note, no titanium, no airplanes. Shades of Arena, Star Trek, 19 January 1967. We are through issue number 10. We have another stand up and stretch, if you like. And I'll take any questions first on words and terminology, then on the rest of the issues. Annie, first on the words and terminology, yes?
So go ahead and get some snacks and give me your questions if you have questions.
Okay, you're talking about the carbon creation and so forth.
Yes.
Carbon. You sounded like the earth was there and the carbon was coming in.
No, I'm only saying that if there isn't any screen to catch it, then it will just dissipate all over the place. I remember I conceded that the scenario from the other side of the fence is completely different. They would start with population Roman numeral 3 stars, then to 2, then to 1. But that is, I don't think I've seen any actual quantifiable formula doing this, except, I've heard about it, but that's about it.
But basically, in other words, if you follow what people are saying out there, you're saying the carbon, the material out there on which the Earth was formed couldn't have had enough carbon, is that what you're saying?
There's not enough supernovae within striking distance of the Earth, or the volume of the Earth, if you like, to account for its carbon.
Whatever material the Earth supposedly accumulated out of, you're saying that material could not have enough carbon because of the supernova and so forth.
Supernovas, the rest of the supernovas are too far away to have distributed the carbon to the volume of the Earth. And it's not even close. This is a naive computation. I said this from the beginning. It assumes ordinary normal physics and a memoryless superposition and so forth. I can see the shaking of your head here.
No, I was just actually looking at the side.
Sure. Again, this is put forward as a computation because many in the public would think of it more along that line than accretion from population Roman numeral 3 to 2 to 1 and so forth, which would be mostly beyond the ken. But that's what people would think. And I'm just saying, suppose you were to follow that line of reasoning, what would be the result?
Okay, have you got somebody that's going to pay for it?
On the computation?
Yes.
No, I'm the first one probably to ever do it.
Okay. The reason I'm saying this is somebody who did have credentials, could get a paper out of this. or so on. They phrase it in terms of unexplained in our field.
Yeah.
You need a publication out of something.
Oh, maybe not.
Somebody out there in the scientific field with all the credentials and everything else, and who has enough background in terms of making publications. Okay, yeah, I'm very familiar with this field.
Absolutely, yes.
Okay, not the scientific side, but very much understands academic publishing.
Yeah.
People do publish things like this, exposing kind of holes in things. But they do it, they have to phrase it in such a way as to make sure everybody thinks that, they're not trying to be a creationist. But it's doable, because, there is actually, honestly, out there, a lot of scientists with integrity who basically do want to solve the problems. And so somebody comes up with something unexplainable, they want to see it.
Yeah.
So, but anyway, the first step on this is getting this in publication, going through a peer review process.
Well, I don't doubt that. I don't doubt that would help. No.
And it has to be somebody that's got the credentials to do it. Okay.
Well, that's all a matter of opinion about what constitutes credentials. For example, I don't have any control theory courses, and yet I have a published paper on it. Nobody disputed the results of it.
I'm talking about the sociology of the field. Okay, I'm not talking about the technology.
Yeah, I understand.
Basically, there's a way people do things out there, and you can do things if you play by the rules. Okay.
Yeah.
Okay.
And you're saying if the guy, no matter how good the scientist is, or his credentials, if he even smells of creationism, they're going to blow out anyway.
Yeah, that's true, but you can phrase it in a way to go out there and
Present the problem.
and just say, hey, this is a problem that we need to explain. Okay.
Well, I'm doing so in this little forum, if you like, and the others as well, to engender any, or should I say, curiosity or interest, so that somebody can come back to me and say, well, you actually need to consider these particular other things in your computation.
There's been a lot of people out there. The whole intelligent design movement was based on growing up and taking things that's already been published by the academic journals and so forth, and showing how they basically have a problem here explaining things from a scientific point of view by keeping God out of the whole situation, keeping intelligence out of the situation.
Well, if you notice, I have been keeping entirely within scientific empiricism this whole talk. I haven't broached the subject. I might at the end, you see, but not here because it's not appropriate. Empiricism is, though.
Well, I know, but that's the way the game is played out there.
Okay, well, I'll be an empiricist.
If you want to play in the game, you've got to run play it by the rules.
Sure, and I play by the rules by going to the same scholarly journal articles and college-level secular science texts that they would.
See, what I'm saying is if somebody does something like that computation, it's into some kind of credible academic publication, then you're giving people more ammunition to work with.
All right. Well,
So if you don't get it publicized through the channels that exist out there, nobody will ever pay attention to it.
well, we do have a room full of people that I hope I've kept their interest. I haven't engendered any of this or even the Big Bang disproof to that field because you only really get one shot, and that I haven't located yet. If I ever do, I'll of course ask other people to kindly submit their comments before I ever even approach the scientific field. I know what it means to get things published too. I'm not a stranger to that. And we do have a few other questions, if we could ask. Yes?
Yeah, I just wanted to confirm, so you're saying the composition of the minerals from the Earth and the Moon don't match up, but the oxygen isotope amounts match up?
There is conflicting evidence in that regard, yes.
Okay, okay.
There's conflict, yes. Any other questions? We have only about 23 minutes otherwise.
Just quickly.
Yes.
The carbon cannot be formed except in supernova.
The secular hypothesis is the triple alpha process, and there is no other secular hypothesis. It won a Nobel Prize in 1983. And it goes by the means that I said. The two helium atoms, which came by fusion from hydrogen atoms, collide to form the unstable beryllium-8 species, and before it can dissociate in 10 to the minus 15 seconds, a third one comes to join the fray. This is close to a triple interaction at the same time, which is regarded as statistically impossible scientifically, so it's done in stages to overcome that small barrier. It's still improbable, though. It can only take place at one nuclear resonance, only in red giant stars, nearing the end of their phase, and only be disseminated by supernova. These are not up for dispute as far as the scientific community is concerned. That's what they're hanging on to, and they have been hanging on to ever since the work of Fowler and two others. I can't remember their names, but ever since the late 1940s, early 1950s. There is no other hypothesis available in the secular community. All right. Anything else for now? We need to at least silence those who would be producing foolishness on the other side. The point is, however, that those people with whom we would desire to at least keep in our orbit but still subdue the foolishness do, in many cases, have the scientific credentials to discuss science. And we need to be at least somewhere in the ballpark to have any ghost of a chance of reaching these people. And it is my hope that some of this material, if not all of it, would be helpful in that regard. I produced this material when I saw not too many people discussing it. I didn't even get into this game until many, many years in, because I thought it already was out there. But then I began to discover little by little it wasn't. And so it is my hope that this material, seen here or seen in the other videos with the same title, would be helpful in that regards. And of course, I welcome comments, suggestions, improvements. In the biochemistry, biology, and information section, issue number 11, how do peptide bonds exist? See a condensation of glycine. Chemistry, with or without thermal vents. Chemistry and physical barriers to formation are substantial. Violates chemistry. C, amino acid molecules. C, the central carbon atom, an attached hydrogen atom, and an attached entity, which may be another hydrogen atom or any of 19 functional groups. Bonded to one side of the central carbon atom, C, an amine group. Think, ammonia has a third hydrogen atom bonded to its nitrogen atom. Consisting of a nitrogen atom singly bonded to each of two hydrogen atoms. Bonded to the other side of the central carbon atom, see a carboxyl group consisting of a carbon atom doubly bonded to an oxygen atom and singly bonded to an oxygen atom, which in turn is bonded to a hydrogen atom. Amine group, carboxyl group, base, acid. The two should form a peptide bond, but the reversible reaction heavily favors starting materials instead. The pattern, NHCHCO, NHCHCO, in bonding is always linear with no branching. Proteins chain from peptide bonds. Consider whether peptide bonds can form out in the open. As in the reaction that we see, the hydroxyl part on the left molecule combines with the hydrogen atom of the amine group on the right molecule. What disappears in solution as a result of forming the peptide bond? A water molecule. Think about Darwin's idea that all living creatures had their eventual origin in a warm little pond. Just how would such a situation be possible when a water molecule must drop out, not be absorbed by the amino acids? Therein is a problem. Okay, so there is no warm little pond, at least not one for peptide bond formation. Thermal vents, because their energy is waste heat and also not site-directed, would help destroy, not form, peptide bonds. In living organisms, For peptide bond formation, amino acids use GTP, that's guanosine triphosphate, to overcome endothermic barriers, and rough endoplasmic reticulum ribosomes to overcome hydrolysis. No one has ever seen any such helpers in the open or synthesized from primitive molecules in the laboratory. Outside of water, how would amino acids find each other on dry land? But suppose that they do. An atmosphere over dry land would be oxidizing or reducing. For an oxidizing atmosphere, an oxidizing agent, for example oxygen, would destroy the bond, and maybe the amino acids as well. For a reducing atmosphere, there would be no ozone layer, and the UV rays would come and destroy the bond, and maybe the amino acids as well. So, which came first? Amino acids, guanosine triphosphate, ribosomes, ozone layer? Which came first, the chicken or its egg? It's to sidestep the Hollywood Squares episode in which Peter Marshall, the host, ruled that a reptile egg came before a bird. Which came first, the chicken or its egg?
Chicken.
God. But of the two, a hen and a rooster came first. It wasn't Adam and Steve Rooster. It wasn't Eve and Guinevere Hen. It was Adam and Eve Chicken. No bonds implies no proteins, implies no enzymes, implies no life. And, as everyone knows, without biochemistry, it's amino world.
Amino, and there's amine old.
Issue number 12. How do proteins have only left-handed amino acids? Non-superimposable mirror image pairs can be labeled L, levorotatory, and D, dextrorotatory, with each pair relative to a central carbon atom, according to the Kahn-Ingold Prelog RS sequence rules. Such molecules, which may be organic or inorganic, are also called stereoisomers, enantiomers, chiral compounds, or optically active compounds. For four constituents, each singly bonded to the central carbon atom in such an organic molecule, the four must be distinct from each other. See that amino acids are such molecules. Source the previous accompanying illustrations, or those on page 14 of Lubert-Streyer's Biochemistry. Stereoisomers, for example, LD amino acid pairs or rubber and gutta percha, are different molecules from each other. Provided there is no bond breaking, one cannot superimpose. In other words, stick one of them on top of the other so that they match. Because of their spatial geometry. For the present, the starting point must have equal probable conditions. The ingredients, energy sources, environment must all be neutral. Any stereoisomers must exist as racemic mixtures. In other words, equally left and right-handed, plus or minus some small difference, a small one if by soil clays, etc. The amino acid pairs found on the Murchison meteorite, which landed on the Earth on 27 or 28 September 1969, had high degree of asymmetry, maybe as high as 68 to 32%, but still nowhere close to 100% to 0%. Stereoisomers have the same melting point, boiling point, refractive index, vapor pressure, chemical reactivity, density, etc. The only way to tell L apart from D would be by plane polarized light, where one rotates that light by so many degrees in one direction and the other by the same number of degrees in the opposite direction, or by reacting the stereoisomers with other already existing stereoisomers. One exception for ammonia sodium tartrate, Louis Pasteur separated L from D with a lens and a pair of tweezers. Any preponderance of left-handed would be due to some unknown mechanism, such as a left-handed electron or meteorite. A natural origin of pure stereoisomers is unknown. Source, page 236 of Morrison and Boyd, Organic Chemistry. Indeed, we deal with optically active substances to an extent that we may not realize. We eat optically active bread and optically active meat, live in houses, wear clothes, and read books made of optically active cellulose. The proteins that make up our muscles and other tissues, the glycogen in our liver and in our blood, the enzymes and hormones that enable us to grow and that regulate our bodily processes, all these are optically active. Naturally occurring compounds are optically active because the enzymes that bring about their formation, and often the raw materials from which they are made, are themselves optically active. As to the origin of the optically active enzymes, we can only speculate. The situation is no better now than when that book was being printed in 1972, and the problem was known for more than a century before that. Every amino acid of every protein of every species is only left-handed. There are no right-handed amino acids in any protein, anywhere. It is immediate that the complete asymmetry is a problem for evolutionists. One cannot legitimately dismiss the evidence for personal reasons or say that molecules have minds of their own. Similarly, for other stereoisomers, there is no left-handed electron. Right-handed amino acids do exist in other structures, for example, bacterial cell walls. Otherwise, humans would not live, as the corresponding bacteria are necessary for the intestine. A bacterium, on encountering a right-handed amino acid, will attempt to turn it into a left-handed amino acid before digesting it, if it can be digested. Isaac Asimov claimed that a left-handed amino acid formed first and thus won out over right-handed amino acids, although the reverse could have been the case instead with equal probability. One over the entire face of the globe? As seen earlier, amino acids do not form peptide bonds without both GTP, guanosine triphosphate, and rough endoplasmic reticulum ribosomes. Asimov's response is no retort. No one has ever shown Asimov's claim. Violates chemistry. Mixtures of left and right-handed are not favored. Source, Evolution Possible or Impossible by James F. Cobbage. You might recognize David Cobbage as being the son of this now late Cal State University Northridge professor. But an all right-handed chain would be just as probable or improbable as an all left-handed chain. Regarding central carbon atom bond angles, equal components if and only if equal angles. Embedding a tetrahedron in a cube provides a convenient way to view the tetrahedral bond angle. One can embed two tetrahedra in one cube, for example, all of the red atoms or all of the blue atoms connected to the gray atom in the middle. Since the cube and the tetrahedron are two of only 5 Platonic solids, the embedding may be evidence of design. Applying the law of cosines, the tetrahedral bond angle is the arc cosine of -1/3, which is approximately 109 degrees, 28 minutes, 16 seconds. In molecules such as carbon tetrachloride, carbon tetrafluoride, methane, the first appearance of computing this angle should be in high school Euclidean geometry, but instead usually is in college freshman chemistry. Deviations from the tetrahedral bond angle may help identify an amino acid in question by the stretching or contraction, in other words, compression, per the amino acid's functional group. About mechanistic theories of the origin of life, see source. Chapter 2, Evan Schuet's Flaws in the Theory of Evolution, 1961, mentioning stereoisomers in just 5 words, the development of optic activity, and dismissing evolutionists' arguments in 12 words, step after impossible step is begged in the course of these polemics. And the greatest number of protein-sized molecules one could ever expect to get by chance is 3. Far cry from one living cell, let alone one living creature. See the publisher's note for a summary of Dr. Schuet's numerous achievements. Dr. Schuet, a fellow of the Royal College of Surgeons of Canada, received both his undergraduate medical degrees from the University of Toronto. It is interesting to note that Dr. Schuet was more or less a child prodigy, entering high school at 9 years of age. He matriculated at the University of Toronto at the age of 14, the recipient of a Carter Scholarship based on a record high score. Doogie Howser. An all-around athlete, he was intercollegiate light heavyweight boxing champion, a member of the wrestling and track teams, as well as of the college crew. Hulk Hogan before his demise. He is a member of many internationally known societies, including the Canadian Physiological Society, the American Society for the Study of Fertility, the British Society of Endocrinology, the American Geriatric Society, an associate member of the Royal Society of Medicine, and a member of the Canadian Authors Association. He is listed in American Men of Science, American Men of Medicine, in the Canadian Who's Who, and in the Directory of Medical Specialists. He has been the honorary president of the Osler Society. Dr. Schuet is a lecturer of international renown, the author of numerous books of verse, and the editor of Summary, an annual medical journal. Does the aforementioned sound like someone who has an irrational view of the world? If you still think so, please let me know why you think so. And in case you think that I've been throwing around chemical terms without knowing what I'm talking about, C. An issue of the Register, the official publication of Phi Lambda Upsilon, the National Honorary Chemistry Fraternity. I am a member of this organization and wear that badge proudly, despite being mostly a mathematician. Issue number 13. What turned non-life into life? Suppose there is a dog that's been dead long enough, say 3 or 4 days. One small task, Hercules, breathe life into the dog. I've given you all that the dog has, viz. its heart, blood vessels, brain, cranium, instincts, skeletal structure, backbone, bones, spinal column, nervous system, muscular system, diaphragm, lungs, legs, toes, eyes, nose, mouth, tongue, teeth, trachea, alimentary canal, stomach, intestines, glands, fluids, elimination organs, reproductive organs, kidneys, liver, thyroid, spleen, gallbladder, appendix, skin, hair, tail, etc. I've given it all to you. Just breathe life into it. What's the matter? Is this not a small task? Are you not Hercules? Maybe the problem of breathing life into the non-living is much bigger after all. No kidding. If it's not possible to breathe life into a dead dog, then it's not possible to breathe life into materials made into a dead dog. Or choose another creature, smaller if you like, instead. Even less if the starting point is an all-hydrogen universe. Even less than that for the infinitesimal before a Big Bang. Which never could have occurred anyway. Any number of hypotheses exist. For example, spontaneous generation, Goldschmidt, hopeful monster, RNA, the hero scenario, etc. So far, no hypothesis has even been close, let alone succeeded. Life only comes from life. That's all that anyone has ever known. No, Pasteur only showed that spontaneous generation doesn't occur. Violates physics and chemistry. Life began elsewhere, and some transportation brought that life to Earth. How the first life began anywhere does not depend on location. Also unanswered would be whether that first life anywhere would be subject to the laws of thermodynamics, or whether it was Adam and Eve, first life, etc. Issue number 14. How does metamorphosis occur? There are at least two kinds of metamorphosis, amphibian and insect. This issue focuses on one aspect of insect metamorphosis. A common complete insect metamorphosis cycle consists of 4 stages: egg, larva, pupa, adult. The origin of each stage and of its transitioning to the next stage requires explanation. For present purposes, assume that the origin of each stage and transitioning from adults laying eggs, eggs hatching into larvae, larvae spinning cocoons or chrysalises around themselves to become pupae, all have sufficient explanation. In their mushy state, pupae have no control of their own destiny. Other objections also exist. All camps, young Earth creationists, old Earth creationists, evolutionists, have conceded the mystery in print in recent years. Representative sources. Metamorphosis, a symphony of miracles, Dr. Gordon Wilson, Answers in Genesis, Young Earth Creationists, 1 April 2014. Metamorphosis, the case for intelligent design in a nutshell, Chrysalis, David Klinghoffer, editor, Discovery Institute / Illustra Media, Old Earth Creationist, 2011. The Mystery of Metamorphosis, a scientific detective story, Frank Ryan, Science Writers, Evolutionist, 7 April 2011. A cause without an effect violates mathematics. No matter what the issue, ignorance is no answer or excuse. Diligently seeking the truth but not finding it yet is one thing. We'll have our laboratory books open and record and test those measurements as long as we're allowed to do so. Hopelessly ending for a favorable outcome that may never arrive, buying for time is quite another. If you don't know, then say so. Otherwise, I'll just wait, and wait, and wait. Two can play that game. There is no viable hypothesis yet. Now this.
We might want to look at metamorphosis. Most insects, about 87%, undergo a complete metamorphosis. That is, a larva, such as a caterpillar, builds a cocoon or chrysalis around itself. Its body inside then disintegrates into a thick pulp-like liquid. Days, weeks, or months later, the adult insect emerges, one that is dramatically different, amazingly capable, and often beautiful, such as a butterfly. The food, habitat, and behavior of the larva are so different from those of the adult, it's hard to imagine. What mutations could improve a larva? Certainly none that destroyed its nerves, muscles, eyes, brain, and most other organs, as occurs within the cocoon. So even if the larva improved, it later ends up as mush. From the evolutionary standpoint, liquefying complex organs is a giant step in the wrong direction. Millions of changes inside the thick liquid never produce something survivable or advantageous in the outside world until the adult completely forms. How did the genetic material for both larva and adult develop? Which came first, the larva or the adult? What mutations could transform a crawling larva into a flying monarch butterfly that can accurately navigate 3,000 miles using a brain the size of a head of a pin? Indeed, why should a larva evolve in the first place? Because it can't reproduce.
Dr. David Lehman. Issue number 15. How do major morphological changes occur? Note, since morph means change, morphological change is a repetitious phrase like pin number, Rio Grande River, Department of Redundancy Department, or Department of Ambiguity Department. Darwin's biological hypothesis, also known as evolution, which we call goo to zoo to you. Nowadays, the public thinks that the hypothesis is true because of supposedly overwhelming evidence. Even with DNA research, such a hypothesis has not satisfied, among other things, wholesale organ changes required, unexplained high-level transitions, chromosome fixity in both number and content. Regarding wholesale organ changes required, see a chart showing that. Bullet. A fish to amphibian transition would require, among other things, no metamorphosis to metamorphosis and two-chambered heart going to three-chambered heart. Bullet. An amphibian to reptile transition would require, among other things, metamorphosis to no metamorphosis. External fertilization to internal fertilization. A reptile to bird or mammal transition would require, among other things, scales to feather for birds, scales to hair for mammals, cold-blooded to warm-blooded. I'd really like to see that one. Archaeopteryx is a reptile to bird transitional form. Archaeopteryx is a bird, not a transitional form. Dinosaurs may have been warm-blooded, not cold-blooded. Such a thought would not rule out other cold-blooded reptiles. But even if dinosaurs had been warm-blooded and no other reptiles could be suitable starting points, then cold-blooded to warm-blooded would now become a new requirement for an amphibian to reptile transition. Bullet. A bird to mammal transition, not generally advocated, would require, among other things, wings to hands, paws, nose, and feathers to hair. Such transitions would also need to be true of both male and female, co-located to form a colony. Recall the forestalling in Morningside of the Mountain. So not one of these has any reasonable hope of being explained by anyone, anytime, close, soon, or ever. No one knows how to perform any of those changes. If you think otherwise, then show all the rest of us how. Knock yourself out. One may argue fish, 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 or amphibian, 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 etc. But as weak as any supposed low-level transition may be, the weakest chain links are the unexplained high-level transitions, which must occur for evolution to be true.
Well, never mind, evolutionists still insist that feathers evolved from reptile scales, specifically dinosaur scales, and to prove the point, they say that feathers and scales are so similar you can hardly tell them apart. Have you noticed that? One of the first people to say this was Gerhard Heilmann back in 1927. In his book, The Origin of Birds, he says the most striking peculiarity of birds is their plumage, which apparently has nothing at all in common with the scaly covering of reptiles. So much more surprising is it, on examining these structures in the microscope, to learn that the feather is nothing but a further development of the scale. Alfred Romer, very distinguished evolutionist, says birds have been called glorified reptiles. Feathers are in reality almost their only distinctive feature. And he says, although these structures seem quite different from the horny scales that cover a reptile's body, the difference is in reality not very great. Well, you can look in your Encarta encyclopedia, if you have one on your computer, look up feathers and they will confidently declare that the feather is a horny outgrowth of skin peculiar to the bird, but similar in structure and origin to the scales of fish and reptiles. So I thought we'd do a little test. I had a laboratory technician that worked for me. They had a pet boa constrictor. And I said, hey, the next time that little rascal sheds its skin, why don't you bring it on in and we'll look at it in the microscope, because I understand you can hardly tell a reptile scale from a feather. And so she did. She waited, and when this little rascal shed his skin, and by the way, I want to point out that no snakes were destroyed to do this study. We waited until they shed naturally. She brought the skin in, we put it under the microscope, and we magnified it. And this is what a boa constrictor scale looks like here. You can see the others around it. And as the evolutionists have told us, if you look at them in the microscope at least, they are remarkably similar to a feather. So then I took a picture of a feather, and I want you to see if you can tell the difference. So you may want to clean your glasses or something right now. If you got this one in mind, okay? If you get confused, just look at the top. It'll tell you which is which. Okay, that's the scale. This is a feather. What do you think? Should I go back and forth? You got it down, or... I mean, why do they say they're similar when they're absolutely not similar? In fact, I'll go further than that. They are totally different Their mature structure is dissimilar, their function is dissimilar, their embryological development is dissimilar, their mechanism of growth is dissimilar, their mechanism of replacement is dissimilar, their chemical composition is dissimilar. And let's just look at the obvious. Scales are like folds in drapery, like drapery pleats. It's all one sheet. That's like when a reptile sheds scales. He doesn't shed them one at a time or two at a time, does he? The whole thing comes off as one sheet. In fact, reptiles typically have two layers, won't they? An outer layer and an under layer. When they shed the outer layer, then the under layer is exposed. Why do they do that, by the way? Why do they shed their skin? Because they're growing. Now, I want you to think about this. You get a box through the mail, and you're wondering what's in the box. You open up the box, you know what's in the box? A bigger box. So you shed the outer layer because the under layer is bigger. You got to think about that a while. Let's look at that boa constrictor skin. The tail's in the direction of the arrows. So to your upper right, that would be the tail. I don't know, 1/4 of a mile up there or something like that at this magnification. And you can see the scales are arranged in rows, sort of on the bias with the long axis of the snake. If we get a hold of the right side and flip it over like the page in a book, this is what the underside of the skin looks like. And so now the tail's in the direction to the upper left corner. And again, for those of you in the cheaper seats, let's magnify this a bit. This is where one scale just fit right underneath here. It fit right in there, so when the skin pulled off, that scale pulled right out of that pocket, like taking your hand out of a glove. And that's the way the scales are put together, is one continuous sheet. Now, feathers are completely different. Feathers grow out of follicles, just like hair. Hair grows out of a hair follicle. Feathers grow out of a feather follicle. But I'm here to tell you there's no such thing as a scale follicle. Now, what is a follicle as it relates to feathers and hair? It's a tube-like depression in the skin. You see it here. Goes down deep in the skin. All of the growth occurs in the bottom in what's called a growth collar. The feather grows out sort of looking like a thick hair. And when it comes out of to the surface of the skin, it all unfolds to make the feather. This is the way the feather follicle looks down in the skin. All of the growth is occurring here, and the feather's alive at this point, but as it makes all of its parts, it dies. It goes through a programmed cell death so that the feather that emerges from the skin is completely dead. This is how it all develops. Inside the shell here, we have what we call a pin feather. If you peel this shell away, you can see that this is the growth region at the bottom. The shaft goes up along the backside there, and then the barbs grow off this growth ring, and those little barbs get longer and longer. They grow from each side and meet at the other side. When the feather comes out of the follicle, this cylinder opens up, the barbs all swing down, and you get this big broad feather out of a hole in the skin that's not much bigger than a shaft. And that's the way each feather grows from living cells, goes through a programmed cell death, and rises up out of the follicle in that way.
Dr. David Menton. Regarding transitions, each such transition required by evolution would be what level on this diagram? Not species to species, genus to genus, family to family, order to order, but class to class. It's doubtful anyone has claimed, let alone seen, let alone successfully demonstrated a species to species transition. At least one in which the different species in question looked nothing like each other. But certainly no one has claimed, let alone seen, let alone successfully demonstrated a genus to genus, let alone family to family, let alone order to order, let alone class to class transition. What would be the greatest probability of satisfying Darwin's hypothesis, also known as evolution, even if still remote? Each and every such transition would need to take place in just one generation. But if any such transition would instead require more than one generation, then each intermediate form would also require its own class-to-class transition from each form to the next, further increasing the overall remoteness. Never mind any higher level transition, for example, from invertebrate to vertebrates, phylum to phylum, or even worse, from bacteria to invertebrate, kingdom to kingdom. Getting bacteria from non-living material would borrow trouble from what turned non-life into life, issue number 13. Regarding chromosome fixity. Apparently, no non-deleterious path from any creature's chromosomes to any other creature's chromosomes exists, especially humans 46. Even so, if claiming that a creature can turn eventually into another creature, one should state which specific creature turned into what other specific creature by what specific means. Rarely, if ever, does anyone do so. Instead, the foregoing is a toxic taxonomic nightmare. Evolution of the gaps, if you please. Violates chemistry and possibly physics. Issue number 16. What creates information from gibberish?
Intelligence.
Not so fast. You might get a surprise for this one. On information. Source. Donald E. Johnson. Chapter 9, Section 1, Paragraph 1. Quote, the failure of purely physical theories to describe or explain information reflects Shannon's concept of entropy and his measure of news. Information is defined by its independence from physical determination. If it is determined, it is predictable and thus by definition not information. Yet Darwinian science seemed to be reducing all nature to material causes. If a system has only signals, in other words, exhibits no novelty, only known laws, such as those in mathematics, physics, and chemistry, then the system has no noise, in other words, no information. On the flip side, if a system has only noise, then the system will never exhibit anything else. In that sense, information equals noise equals surprisal is about the same as gibberish. Curiously, evolutionists might well disagree with that assessment. There are always measures of pseudo-randomness, the closest approximation of randomness. Oh, autocorrelation function, periodic or aperiodic, generally aperiodic. Oh, ambiguity function, the glorification of the autocorrelation function. Burying a radar code requires working with such functions. Source. Merrill I. Skolnick's Radar Handbook, a reference book that is used by virtually every aerospace company in the world. Information entropy versus energy entropy amounts to scrambling characters versus heating gases. Both entropy types have the same mathematical form. Think monkeys and keyboards. Picture of Merrill I. Skolnick in the 3rd edition of the Radar Handbook. In contrast, recall that communication requires the following. And what about their origin? Bullet, sender tuned to a receiver. Bullet, receiver tuned to a sender. Bullet, pre-existing language and context. Bullet, medium that promotes signals much more than it interferes with noise. Bullet, separation of signals. Physical determination from noise, randomness. Bullet, performance of a sample task to show that communication is occurring. All of life requires communication. DNA and proteins code for each other, forming another chicken and egg problem. Even more challenging if the DNA and proteins don't both exist. Currently, there is no viable hypothesis about the origin of communication. Claim all attempts so far violate mathematics, physics, and chemistry. Final conclusion. All evolutionist proposals must be corrected, set aside, displaced, or abandoned, and their makers held responsible. Can anybody name any of these 7 famous modern scientists? One at a time, please. Any?
So Isaac Newton, number 2.
Isaac Newton is number 2 in the first row. Correct, yes?
Kepler on the upper left.
Kepler is the first one in the first row. Correct. Any others? They're all very famous. Yes?
Pasteur in the bottom center.
Pasteur is in the bottom center. That's correct. Any others? Yes?
William Gottfried Leibniz, the
Nope, no Leibniz. Not in this picture. Any others? Let's see if anybody else can. Anybody else? No? Okay, then we'll take it.
Faraday on the right.
Faraday is the last figure in the top row. Yes. And
Not sure about the other 2.
there's 3 to go.
Oh, right, 3.
Any others? Any other thoughts? The top row with the red, it was said that he was more influential than Jesus, and I'm sure that he would have rolled over his grave to think that that was true, and that was printed a few years ago. Does anybody recall who that would have been? Think about your taxonomy.
oh, Carlos Linnaeus.
Linnaeus, yes, the one in red. Now we have the left and right on the bottom row. Anybody have any idea?
Hint.
Hint, the one on the left side is paradoxically associated with a certain demon. He died at age 48.
Matthew. No, not it.
Nope. Any idea who that would have been? He, in fact, you might have seen a T-shirt that said, "And God said," and then these laws. Huh?
James Clerk Maxwell?
Maxwell is correct, yes. And then we have the one on the right side, on the bottom row. Think about your medicine chest. We still use this product to this day.
Lister.
Lister is correct, yes. So, those 7 plus 9 others you can see in this list, some of which you folks were naming. What else did these 16 have in common?
Believe in a creator.
They were not evolutionists. There were some in those days, but not too many. Now, yes?
There are Christians.
Oh, sure. Yeah, but that's the point I'm trying to drive at here. Some of them we may or may not know altogether about their lives, but we do know that they weren't evolutionists. Now, altogether, this talk has so far been entirely in empirical science, as it should be. We also hold to a book very dear, and it has some things to say about science. May I mention just a few in our closing moments? In the beginning, God created the heavens and the earth. He made the stars also. Who is this that darkens counsel by words without knowledge? Gird up your loins like a man. I will question you, and you shall declare to me, where were you when I laid the foundations of the earth? Tell me if you have understanding. Who determined its measurements? Surely you know. My favorite is a mathematician, adding one thing to another to find the sum. Come now, let us reason together, says the Lord. No one considers, nor is there knowledge or discernment to say, regarding a block of wood, half of it I burn in the fire, I also bake bread on its coals. I roasted flesh and have eaten, and shall I make the residue of it an abomination? Shall I fall down before it? In other words, the essential nature of an object, where we take one sample from one place, we're just as likely to get the same results as if we take another sample from the same object. I have used a number of references in this talk. The red ones are the neutral or those on the other side. The green would be said to be on our side. Those 10. And these additional 8. I have 15 of them up here. There are some credits for those who were responsible for a lot of the slides. Originally it was Joe Emilio. Tom Canfield, sitting in the back, has been very helpful in any number of regards, especially with many of my questions. Chad Williams, the Navy SEAL, contributed early on one slide, the end. Now, I don't know if we can entertain any more questions because it's so late, but I will if anybody wants to.
For those that have to go, you may go. Not to rush you out of here, but just want to give you an opportunity if you do need to go. And we'll take questions and
Specifically about 11 through 16, and then any others after that. All right? 11 through 16. Any issues, any questions about issues 11 through 16, and I will put up those issues now so that you can see them. Any? Yes.
You were saying there's only left-handed for amino acids for proteins. Are there, in other structures, are there right-handed items?
Yes, I mentioned that in bacterial cell walls, there are right-handed amino acids. Otherwise, you wouldn't have any bacteria left because the enzymes would dissolve them. And we wouldn't be alive because we need those bacteria in our intestines.
Okay. So, like if you were going to say a chair or something, is there a right and left in certain metals or substances?
Well, they have to be specifically so that they are mirror images, but as I mentioned before, not superimposable. You can't stick one on top of the other so that they match. That's what distinguishes a left from a right-handed or just chiral compounds in general from each other. If you could stick one on top of the other, there wouldn't be any of this left and right-handed. For example, a methane molecule, a carbon tetrachloride molecule, a carbon tetrafluoride molecule, there's no left and right in that. They're all identical. In fact, even if you replace two of those four entities, you would still have an equal number on the bottom, so it still wouldn't convey anything like that. There's kind of a meso circumstance that involves trying to distinguish the right from left-handed entity that's still left, but there hasn't been any success that I know of in that regard. Yeah, any other thoughts that you had on that? Okay, good question. And any other questions? Through on 11 through 16, any? No? Okay, then any on any of the issues that are left over? Any at all? No? Okay, then I want to thank you very much for your time and attention.
excellent. Thank you so much.
He has to help me take these out.